And in this lecture principle we have discussed on principle of impulse and momentum. Sometimes the force acts for such a small time interval and have such a high magnitude that it is not possible to measure any of these two. So this force is called as impulse force. So F equal to ma, force equal to mass into acceleration. So we have to derive that equation d by dt along with the time. So mv. So F equal to m into dv by dt. Okay. So F equal to m into dv by dt is also equal to F into dt equal to m into dv. Okay. So we take t1 respect to integration with respect to t1 and t2. So f into dt equal to f into integration of v1 to v2. So finally we have got f equal to t2 minus t1 and equal to m equal to and m into v2 minus v1. So ft equal to m v2. So ft equal to m v2 minus m v1. Okay, so total impulse on particle is equal to the corresponding change in momentum in that time interval. So next point is work of a force. So work equal to F into dx. Look at this diagram. Spring mass system is will be there. Suppose the initial stage is this is a, there will be no any force apply on that. So y0 is equal to its deflection and m equal to mass applied on the spring. So unstraight, this is a unstressed stage. Then initial stage y1, some distance will be initially some distance will be created, and then final stage y2 m. Okay, so from this we have to discuss on the work. So initial tension equal to y1 minus y2, sorry, y1 minus y0, initial tension, initial extension. Okay, and final extension y2 equal to y2 minus y0. So work done by the spring moving from y1 to y2 equal to, so equal to work done equal to 1 half k y1 minus y0 bracket square minus 1 half y2 minus y0 bracket square. Okay, so after that, so this is the work done, and then next one will be the energy. One second. So next one will be the energy. The energy of the body is the capacity to do work. So mechanical energy can be divided into two parts due to position of the body, that is potential energy, and due to motion of the body, that is kinetic energy. So kinetic energy equal to 1 half mv square, and initial kinetic energy equal to 1 half mu square, and final kinetic energy equal to 1 half mv square. So law of conservation of energy. So energy can neither be created nor be destroyed, but it may be changed from one form to energy from another form. Okay, so this is a law of conservation of energy. I repeat this sentence. So energy can neither be created nor be destroyed, but it may change from one form of energy to another form of energy. Okay, so in next point, principle of work and energy. Consider a body of mass m moving with constant force which is displaced for x displacement. Velocity of the body changes from v1 to v2. from Newton's second law of motion, we have already find this force F equal to, we have already find this F equal to mass into acceleration. Okay, so by using this, m dv by dt equal to dv by dx into dx by dt equal to v1. Okay, so F equal to m into dv by dx into v. So F into dx equal to mv into dv. Applying integration on both sides, so x1, so integrating x1 to x2, integration of f with respect to x1 and x2 dx equal to v1 integration of v1 to v2 mv into dv. So by finding out this integration, we have to moving forward by using this uh, relation, complete relation, we have to moving forward by directly to come to end directly with the work done by force. So u1 to, so u1 to kinetic energy 2 minus kinetic energy 1, final kinetic energy and minus initial kinetic energy K E1. Okay, so next term is power. Power is a rate of doing work is known as power. Okay, so power equal to work done per second, force into displacement divided by time, force into displacement divided by time. So displacement upon time is, it is a velocity, so force into velocity, so power equal to F into V. Okay, this is a simple equation. Okay, and unit of power is Newton meter per second or joule per second, or it may be MKS unit will be metric horsepower. Okay, next point is impact, a collision between two bodies which occurs in a very small interval of time and during which the two bodies exert on each other relatively large force is called as impact. Different types of impact are direct impact and indirect impact. Okay,